JMath.
Welcome to a video on general solution. So this is the last part of basic trigonometry. So we learned reduction formulas, identities, those triangle sums, and now we're getting to general solution. So there are many ways to do general solution. So I'm going to show you the quadrants and the reference angle method to doing general solution. So here are some steps on the left. As we go through the question, I will touch on each bullet point, but you're welcome to jot this down and try it for yourself. So let's do the one that says sine 3x is equal to minus 0.2. So firstly, I need to get sine and the angle alone. That is already perfect in this case. So I can't take the 3 over. It's part of the x, part of the angle. Okay. Then I need to get the quadrants. So I can see there's a minus on the other side. So therefore, I can just quickly do a little cast diagram and check where will sine have a negative answer. And that's quadrant 3 and quadrant 4. So when I write down the quadrants and the reference angle, I can say I'm going to work in quadrant 3 and in quadrant 4. Okay, so now for the reference angle, I need to say shift sine of 0.2. Now I'm not going to include the minus. I only use the minus to get the quadrants. So shift sine of 0.2. So that tells me my reference angle is going to be equal to 11.54 degrees. Okay, perfect. So now I can go and get the solution to this question. So I'm going to start off by saying, okay, so I'm going to work with quadrant 3, and in there, 3x will be equal to, so quadrant 3 is 180 plus the reference angle, so plus 11.54, and then plus k 360. Always please remember to just write k is an element of z. I only need to do that once in every sum, but I'm going to lose a mark if it's not there. So now I can just solve this equation. So another name for general solution is also trig equations, because I want to get x alone. So in this case, I'm just going to keep the 3x there, and then I'm going to just, on my calculator, just do 180 plus 11.54, and that's actually going to give me 191.54 plus k 360. Now I'm going to divide by 3, and that would be my answer for the third quadrant. So I can see my final answer will then be 63.85 degrees, and because I divided by 3, I also need to divide the k value by 3. Perfect. That is now my answer. I also said I have a solution in quadrant 4, so therefore I can say, okay, but 3x is also equal to 360 minus 11.54 plus k 360. Therefore 3x is going to be equal to 348.46 plus k 360, and then x is going to be equal to 116.15 degrees plus k 120. Perfect. That is the general solution for that sum. In the next example, I want to get a sine or a cos or a tan alone on one side. Now, in this case, that's going to be a little bit more tricky. When this happens, try and use your identities or your reductions. And in this case, I can see I'm going to have 2 sine theta, and then this sine 90 minus theta. Okay, I know that is cos theta, cofunctions. And I'm going to actually move it to the other side. So that will give me 5 cos theta. So now when this happens, and the angles are exactly the same, I can actually divide both sides by cos and change it into a tan. So if I divide this by cos, so I'm only writing this for you, you really don't need to write this. And I also want to divide the 2 to get to the other side. So therefore, this answer will then be tan theta is equal to 5 over 2. Perfect. Now I have a sine, cos, or tan alone on the one side, and I can start with my quadrants and reference angles. So now with tan, it depends on your teacher. So if you have an old school teacher, they are going to tell you that tan only has one answer, and you say plus k 180. That's how I was taught. That's how generations before you were taught. But recently, the textbooks changed, and they said, okay, but for all of them, we're going to do plus k 360, and we're going to treat tan just like the others. This is really your choice. Okay, in a matric final, they are going to mark it correctly if you say plus k 180, or if you do both options. For this video, I'm just going to do both to stick with the textbooks. So the quadrants we're going to work with is where tan is positive. So that is quadrant 1 and quadrant 3. My reference angle, I can now just say shift tan of 5 over 2. And my calculator tells me that is 68.2 degrees. So now I can go for the solution. I know I'm working in quadrant 1. So it's theta is equal to 68.2 degrees plus k 360. And then I need to tell them, but k is an element of integers. That's it for quadrant 1. Yes, now I can move over to quadrant 3, and then the answer would just be 180 plus reference angle, so 68.2, plus k 360, and therefore final answer is just going to be 248.2 degrees plus k 360. And that's it. That's my final answer. So part of general solution you need to know is that you can also sometimes get asked specific solution. So I immediately know a sum is specific solution if they add this part to the question. Okay, so all that means is I'm just going to add a step to the very end but the rest is everything is the same as a normal general solution sign. So once again, I just need to check, is sine alone? It's as alone as I can get it because the rest is protected by a bracket. So sine is alone, then I can just check, okay, which quadrants am I going to work in? It's positive, so it's 1 and 2. And then to get my reference angle, I'm just going to say shift sine of 0.4, and that would equal 23.578. So I'm just going to say that is 0.58 degrees. Okay, great. So to get the solution now, I need to take this entire bracket as what I'm going to write on the left. Okay, and then I'm going to algebra until theta is alone. So I'm just going to do it here to give myself some space. So quadrant 1, I can say is 2 theta minus 15 equals just reference angle. So 23.58 plus k 360, and I know k is an element of z. Okay, so now, like I said, I'm just going to algebra until theta is alone. So this would be 2 theta is going to be equal to 38.58, and theta is going to equal to 19.29. And that is still plus k 360, and this one is plus k 180. So now if I do quadrant 2, I have to start with the whole bracket again. So 2 theta minus 15 is now equal to 180 minus reference angle. Okay, and I see 2 theta is equal to 171.42 degrees plus k 360. I forgot to add it up top, so please don't be like me. Just add it there. So then I can say, okay, but theta will then just be 85.71. Okay, so, and I need to say plus k 180. Perfect. If the question just asked me what is the general solution, I would stop there and I would get full marks. But now they asked me, but solve for theta specifically between minus 90 and 270. Okay, so now we go over to specific solution. And here in the blue block is the steps for specific solution. So you can do this manually and just sub in a -1, a 0, and a 1 into both k values and then get the answers. Or you can use technology and just take your calculator and follow these steps. So mode table, type in the left part into fx, the right part into gx, and then tell them to start at, let's say, for example, -3, end at +3, and your step is always 1. Then you just check on screen which answers fall between minus 90 and 270. Okay, so here I did it on my calculator, and these are the answers that I got. So I now just need to rewrite it in this form where I say, okay, but theta is an element of, and then please try to make your best rendition of a curly bracket. I am still struggling after 20 years of doing math every day. Curly brackets are not my thing. But anyway, check your calculator, and I'll just fill in the bracket, and that would be your final answer. There we go. That is the specific solution to this question. So remember, you only do specific solution if that part in green that I highlighted, if that is present in a sum. Otherwise, you can just leave it at the step where you say plus k 360 or plus k 180 as your simplified version. So now in exams, they will always try to make it a little bit more difficult. So in this case, I need to still try and get sine or cos alone. Now, I have too many options here, so I need to try and change everything to sine or everything to cos. Now, the 3 cos theta, I can't do anything there. There's no identity that will help me there, but sine squared, I can definitely change. So I'm going to use the grade 11 identity that says sine squared is equal to 1 minus cos squared theta, and then plus 3 cos theta, and I'm going to bring the 4 over, so it is equal to 0. Now I can multiply in 4 minus 4 cos squared theta plus 3 cos theta minus 4 is equal to 0. I'm just going to simplify now. So there's a plus 4 and a minus 4. That just becomes 0. And I'm going to move everything else to the right. So I can then say this is going to be 4 cos squared theta plus 3 cos theta. At this stage, I'm going to have to factorize. This is luckily just a common factor. So I'm just going to say 0 is equal to cos theta. And then what's left over is 4 cos theta plus 3. Okay, so now I need to general solution with both of those. So this question is going to have 4 answers. So my first one is just cos theta must be equal to 0, and then or that bracket must be equal to 0. So I'm just going to simplify already and say, okay, so if I get cos theta alone, this would be minus 3 over 4. Okay, great. Now I'm going to have to get answers for both of them. Now with the cos theta equal to 0, you can really take a shortcut. So if you just look at the cos graph, I can see the cos graph is 0 at 90 and at 270. So if you know your work, you can really take a shortcut and just say, okay, from the graph, I know that theta is equal to 90 plus k 360, or theta is equal to 270 plus k 360, because I looked at the graph. You will get full marks for that. But you can also do it the long way and get the reference angle and the quadrants, and you would get to the same place. I'm just going to take the shortcut for now because you guys know the method already. Now with the other one, cos theta is equal to a negative. Let me just change colors so you can follow easily along. Okay, so if I do quadrants, I can see cos is negative in quadrant 2 and quadrant 3, And now my reference angle, remember, I'm just going to say it is shift cos of 3/4. So if I just say shift cos of 3/4, I get that my reference angle is 41.41 degrees. Again, so in quadrant 2, I can just say theta is equal to 180 minus reference angle, and then plus K360. And I could have at this stage already said K is an element of Z. You just need to write that once in every sum. So there I already wrote it, so I don't need to copy it again. Final answer for quadrant 2 will then be 138.59 degrees plus K360. I need to also do quadrant 3 now. So therefore, theta is also equal to this very same thing, but now it's 180 plus 41.41 plus K360. And this final answer would then be 221.41 plus K360. Okay, that was a big sum. Remember, we needed to get 4 answers for theta. Final question we're going to get to, also saved for exam, so this would definitely be a level 4 question. And if you haven't done an example like this, or there's maybe in some textbooks there's two or three examples like this, but please be awake and check for this one in an exam. I hope you never see it, but let me prepare you if it is there. So sine squared plus 7 sine theta cos theta plus 2. In the left one, I needed to choose, am I going for sine or going for cos? There was a single cos in my middle term, so I didn't have an option. I couldn't change that one, so I had to change the sine squared. In this one on the right, I have a sine theta and a cos theta that I cannot change. Now, in grade 12, you learn about double angles, and that looks very close to the sine double angle. But in general solution, I want all the angles to be single or all of them to be double, so it's not going to help me to change only one of them. This is a very specific case, and this 2 is the key to this entire sum. Okay, let me show you what you're going to do. So sine squared theta, I'm just going to keep like that, plus 7 sine theta cos theta. That 2, I can say is 2 multiplied by 1, and remember 1 is equal to sine squared theta plus cos squared theta from the grade 11 identities. So I'm actually then going to multiply the 2 by that, and that's how I'm going to be able to factorize this sum. After writing all of that out, adding the like terms, we get to 3 sine squared theta plus 7 sine theta cos theta plus 2 cos squared theta. Wow. Okay, that thing is a trinomial. So like I said in a previous part of this video, you can change this to algebra if that's going to help you. Let me just show you what I mean. So I can say this is 3x squared plus 7xy plus 2y squared. Now, many of you will tell me, look, that doesn't help me. That makes it more complicated. But for some people, algebra makes more sense with x's and y's. So in this case, if I do the trinomial, you're welcome to go and recheck a video on trinomials or do it with the calculator, or you can do it with the quadratic formula. But this one would be 3x, 1x, there's a 2y, there's a y, because if I multiply these two, I get a plus 6. If I multiply these two, I get a plus 1, and that gives me a 7. Everything is just pluses, and that would be the brackets. Now I can just change all the x's into sine and all the y's into cos. Okay, so that's your one option. You can go for that. But let's now go back to the trig. So like I just saw, this will be 3 sine theta. I need to multiply that just by sine theta. And then this would be 2 cos theta, and this would just be cos theta. Everything, luckily, is just plus. Now, I have a trinomial. Now I can just say each bracket is equal to 0. So therefore, 3 sine theta will be equal to minus cos theta. And on the other side, or sine theta is equal to minus 2 cos theta. Okay, I didn't give myself much space, but let's try and finish this. So now I can divide everything by cos to make it a tan. So this would be 3 tan theta is equal to minus 1, and therefore tan theta is equal to minus a third. In the other side, I can divide, and I can see, okay, but tan theta is going to be equal to minus 2. Great. Now I need to general solution both of those, and that's how I get the answer. So if I do the one on the left, I will just say, okay, so my quadrant is definitely going to be quadrant 2 and quadrant 4. Okay, so I'm going to just take the shortcut just to save space in this, and I'm only going to do one quadrant for tan. Like I said earlier, depending on your teacher, you can choose either one, or you must then just do quadrant 4 as well. So to get the reference angle, I'm just going to say shift tan of a third, and that tells me the answer is going to be 18.43 degrees. In quadrant 2, that would just be theta is equal to 180 minus 18.43 plus k 180, because I'm taking the shortcut. Therefore, theta is just going to be equal to 161.57 plus k 180. And now with the other side, I'm just going to say I'm going to work in quadrant 2 again. So my quadrants are 2 and 4 again. My reference angle, shift tan of positive 2, gives me 63.43 degrees. And therefore, my answer will be theta is equal to 180 minus 63.43 116.43 degrees plus k 180. And therefore, the final answer to this question will then just be 116.57 degrees plus k 180. Okay, so these two were quite difficult. You can see I wrote my entire screen full of trig, but just follow the steps. It looks horrible, but if you just follow the steps, it flows nicely. So study hard, and then you can get these marks easily in exams.
If this video helped you, please like and subscribe.
JMath.